Hello and welcome to this section of the MATLAB tutor. We spent quite a bit of time talking about vectors in MATLAB, and that's because vectors and later on matrices form the bedrock for really how MATLAB works. So we spent a fair amount of time with that. We've covered lots of different functions that we can use with vectors to manipulate data. Now what we're going to do is close this batch of lessons out with a discussion of how do we deal with vectors symbolically. And we've kind of done that through the entire course. We've taught the core material, and then we've talked how do you apply it to when you're doing a symbolic calculation. So if you haven't already watched the previous videos dealing with symbolic math in MATLAB, please do that now, and then this video will make a whole lot more sense. Let's say we want to define a vector, x, and we want to make sure that it's defined as a symbolic entity. So the way you do that is syms x. This is the command that defines x as a entity, and it defines it symbolically. And you can see over here that it's a symbol, SYM. That means this guy can hold things that are not just decimals. It can hold pure fractions. It can hold algebraic expressions. It can hold things that are things other than just pure numbers. So for the purpose of this, let's go ahead and assign something like, let's say x is equal to, and we're going to open up a matrix. And we could do lots of things here. We could do 4, 6. Now over here, let's say we want to put 1/2 in here. If we just put 1/2 like this, then MATLAB is going to treat it as 1 divided by 2. It's going to put 0.5 in there. We want it to treat it symbolically, so we wrap it in a symbol guy like this. That means that this vector now contains the number 4, the number 6, and the symbol 1/2, which it does not actually do the division and just holds it as a symbol. So I can do, 3/4, something like this. So now I can hit enter, and notice my vector has 4, 6, 1/2 as an entity, and 3/4 as an entity. And notice over here in the workspace it says I have a 1/4 symbol. That means 1 row, 4 columns there. So now this is a symbol. It's not just filled with decimals. These two guys at the end, they're symbols. So if I do things like, take the square root of this guy, then it's going to try to do its best to keep everything exact. So what it'll do over here is it'll take the square root of 4 and get this. It'll take the square root of 6 and just put it there. And then the other entities here, it's taking the square root of each of these guys and putting it there. So it's not converting to decimal. It's just keeping everything exact. And in fact, if you want decimals, you can just take the last answer and wrap it in the double command, which converts everything to a decimal. All right. Now, what else can I do with this guy? I can try to do x plus 2 times x. So remember, x is a vector. It contains all of these things. So I'll take the vector x and I'll add to it 2 times x. And notice I have these fractions in here. So if I do everything correctly, I should get some fractions in my answer. It takes care of all the fraction arithmetic and simplifies everything for me. And again, if I want this as a decimal, I can just wrap it in the double command. All right. What if I want to, do square x? In other words, take each element of this vector here and square each element. So if you remember correctly, back when we talked about it, this is how you would write x squared. But if you do it, it's going to give you an error. Sometimes when you're trying to do element by element arithmetic in MATLAB, you might get an error like this. So if you ever get something like that, you might need to force it to do it element by element by putting a dot right in front of your operator that you're trying to actually do. And that's telling MATLAB, okay, do this element by element. So we look at this, 4 squared is 16, 6 squared is 36, and then of course I square each of the fractions properly, and so on. So the key here is you have to define your vector symbolically, and then whatever you put into the vector, you need to make sure that they are also symbols. And that's why back before, when you actually look in our history, you can see that when we put 1/2 in there, we wrapped the symbol command around it, and we did the same thing here. If you didn't do that, MATLAB would interpret this as 1 divided by 2, and it wouldn't be a symbol, it would just be a decimal in there. All right, so I can define another vector. Let me call it y, and I want to define it as a symbolic guy as well. So then I'll say y is equal to, I'll put 4 elements in there so it matches, and I'll do, symbol 11, 21, symbol 5, 6, symbol 6, 13ths, and let's just put pi in there just to be different. So what we have is 3 fractions, these guys here, and then we have the pure number, or I should say the the infinite number pi that MATLAB understands, and that's stored in the vector y. So you can see that the fact that my division, my fractions are still intact, I did all of that correctly. So I can do things like, let me clear the screen. Here's x, here's y. I can do things like x plus y. And because it's 4 elements in each of these vectors, I can add them like this, and I'm adding element by element, and MATLAB will go and add them element by element. So when 4 plus 11 21sts is going to give you this, and I'm adding each element here at the end, I get 3/4 plus pi. So you can do all kinds of things, you know, to try to do manipulations with this. The point is that when you create your vectors, if you create symbols, especially if you want to deal with fractions, you can go and put those guys in there into a vector form, and you can keep everything perfect and everything exact if you want to. And then when you're ready to go back to a decimal, you can do that, right? Now let me clear the screen. Let me create another vector, and let me define that again as a symbol. I'll call that guy z. Let me do it this way, sims z. So I've defined the vector z. Z is equal to, create 4 elements here, 0, 1, 2, let's do 2/3, so I have another fraction here. And then for the last thing, let me do 1 plus 2i. I want to make sure you understand that when you're dealing with these vectors of any kind, you can put complex numbers in there. A complex number is just like a regular number to MATLAB. It can deal with any of it. So you go and hit enter, and I have 4 elements. Here's a number, a fraction that is intact as far as it's still a symbol, and then I have this nice complex number. So I can do things like x plus y plus z, and it'll attempt to add all of the elements together, and notice I have, you know, big fraction here, another fraction, another fraction. The last thing that I have is an addition of things here. I have an imaginary part, and then I have another part here that it's trying to keep as exact as you can. And if you want that into a decimal form, then there you go. And you can see the last entry here is complex because of because of this imaginary or complex number that we introduced. So that's a pretty good overview of what I'm trying to get at here with symbolic capabilities of MATLAB. Let's take it one step further. Let's create another vector. Let's create 2 vectors. We'll call it vector 1 and vector 2, and I'm defining them symbolically so I can see that I've created both of these guys. And instead of putting numbers and fractions and things like that in there, I want to go ahead and actually put an algebraic expression in there. So let me define some other guys. Let me define A, B, and C as symbols also. So now over here, A, B, and C are symbolic variables, and vector 1 and 2 are also symbolic variables. So now I want to construct my vectors. You can do anything you want with vectors in MATLAB. Up till now, we've been putting numbers in there, and then I just showed you how you can put fractions and complex numbers in there. You can put entire algebraic expressions in there if you have some kind of a need. So let's say you want this vector to have 3 elements. It'll be A, and the next guy will be A minus B, and the next guy will be C squared. So this is a vector. Notice that for each element, see, the first element is A, and that's just like in algebra. You don't know what A is. It's just a placeholder for something. The second element is the expression A minus B. The third element is the expression C squared. And when I hit enter, all of this stuff remains intact. My vector is given here. First element's A, second element is this, third element is this. And all of the same things apply as before. If I do vector 1 and I want to extract the second element from this vector, it's going to return A minus B. If I want to extract the second through the third element, then I'm going to extract that subvector, second through the third element. Everything here applies that we've learned before with regard to basically how you work with vectors. So let's go ahead and do something like, let's create vector 2, right? And let's create that as, we'll do A plus A squared for the first element. The second element will be A plus B, and the third element will also be C squared. Okay, so I have three elements. Each element is an algebraic expression. I haven't assigned any values to A, B, and C. They're just totally placeholders. So here, let me clear the screen. Vector 1 is defined as this, and vector 2 is defined as this. Each have 3 elements. Now, I can manipulate these just like I can do if they contain numbers. If I want to add vector 1 plus vector 2, then what's going to happen is MATLAB's going to try to add element by element. So let's see what happens here. I get another vector. So a plus a squared, right, is what I'm going to have right here. Actually, no, my first element over here, my first element in this vector is a squared plus a. So when you add a to it, you get a squared plus 2a. When you add a minus b to a plus b, you get 2a. And when you add this guy, c squared to c squared, you get 2c squared. So you see the rules of algebra are being followed here. If you do things like a divided by b, or I should, let me do it a different way. Let's do 2 times vector 1. So remember, this is vector 1 up here. If you multiply by a 2, MATLAB understands I'm trying to multiply each element by 2, so that's what it did. What if I want to divide these guys element-wise? Vector 1 divided by vector 2. You got to be a little careful, inconsistent, because you have, you don't have things set up right. So let's clear the screen. This is vector 1, vector 2. If you want it to do element by element when you're doing division and exponentiation, you really need to tell MATLAB explicitly with this dot. This dot right in front of the the division symbol tells MATLAB, okay, do this operation, but this is not a standard operation that vectors are allowed to participate in, so go ahead and do it element by element. So when we do that division, it's going to take vector 1 divided by vector 2. So that would be this element divided by this. That's what I have down here, and it's doing the same thing. I can even do crazy things like vector 1 raised to the power of vector 2. Notice I put the dot here telling it do it element by element. And when I do that, I've got all of this stuff. And MATLAB keeps track of it all there. You can even do things like you could do the square root of one of these symbolic vectors. And it'll do its best to take the square root. And finally, let me clear the screen and put vector 1 back on the screen and vector 2. You can think of this as a three-dimensional vector. This could be the x direction, the y direction, the z direction. It's just that the values are totally unknown because I have them in terms of algebraic expressions. So if I wanted to, I could do the dot product of vector 1 dotted with vector 2. Now if these were numbers, it would be easy. You'd be multiplying the corresponding elements and adding them together. And that's what MATLAB is going to eventually do. So you could do dot vector 1 comma vector 2, and look what it's going to have, a whole long expression there. Now notice here you've got some conjugates of some of these vectors here. Conjugate of A, vector A, conjugate of vector A, conjugate of vector B. So you might ask, why is it coming up with this conjugate stuff? It's because A, B, and C are just symbols. They could be anything. So typically when we think of variables in algebra, we think of numbers, but in reality they could be complex numbers. So MATLAB is going to assume that all of the components of vector 1 and vector 2, all of these letters can be complex. So when it does the dot product, it might introduce some conjugates here in order to get the full-blown, the full answer, the rich answer that takes into account that they might actually be complex. And if this guy here, confuses you a little bit, we used that before. We put vector 1 up here and vector 2. Another way to do the dot product that we've talked about in previous sections is to say vector 1 times vector 2, but because these are both horizontal row vectors, you need to put a transpose on the second vector, so it's basically takes vector 2 and turns it into a vertical vector, so you can multiply across and down. And this answer that we get is exactly what we got for when we use the actual function. And furthermore, we can do the cross product by taking vector 1 and crossing it into vector 2. And it will do all of that math behind the scene and come up with a pretty big answer because the cross product, is a lot of terms. So for the x component of the cross product, that would be the x component. For the y component of the cross product, that would be that. And for the z component of it, that would be that. And that is about everything I want to say about dealing with vectors in the Symbolic Math Toolbox in MATLAB. Most of the time you're going to be importing data, you're going to be manipulating data and doing numerical calculations. That is really the strength of MATLAB. But if you define things in terms of these symbols, then you can create these long, complicated vectors that involve basically expressions it allows you to work in terms of pure math without actually knowing any values of anything. And occasionally you might have a problem where you might have to write a vector down symbolically and then manipulate it, and MATLAB has the capability to do that. So pull this out, make sure you understand it. Doing this kind of stuff is very important. Vectors are really the bedrock of how the program operates. When we get into matrices here quickly, we'll start to expand all of these concepts in terms of matrices, full-blown matrices, and you'll again see exactly how MATLAB can be made to work with more complicated problems.